Common Core Algebra 2, Lesson 3, Long Division. Again? Yes, we're doing long division again. So use the long division algorithm to determine the quotient. So I'm going to use long division to divide 2x cubed minus 13x squared plus x plus minus x plus 3 divided by 2x plus 1. So we say what times 2x, we just look at the 2x, ignore whatever else is there. What times 2x gives me 2x cubed? Well, that's going to be x squared. Now we go through and multiply. X squared times the whole divisor. X squared times 2x gives me 2x cubed. X squared times 1 gives me plus x squared. The next step in the long division algorithm is to subtract. And the way that we subtract is we go through and we change everyone's sign. So instead of a positive 1, that is now a negative 1. 2x squared minus 2x squared is 0. Minus 13x squared minus x squared is minus 14x squared. Now we restart the algorithm. What times 2x gives me minus 14x squared? Don't forget to bring things down. What times 2x gives me minus 14x squared? Minus 7x. Minus 7x times the whole divisor. Minus 7x times 2x is minus 14x squared. Minus 7x times 1 is minus 7x. Now we subtract. How do we subtract? We change everyone's sign. And we get 0 plus 6x minus x plus 7x is plus 6x plus 3. Restart the algorithm. What times 2x gives me 6x plus 3? 3 times 2x is 6x. 3 times 1 is 3. We subtract and get a remainder of 0. So the quotient is x squared minus 7x plus 3. If you did this with the reverse tabular method, you get the same answer and the process would be exactly the same. Number 2, find this quotient. So we're dividing 3x cubed plus 4x squared plus 7x plus 22 divided by x plus 2. We say self. What times x gives me 3x cubed? Well, that's going to be 3x squared. Multiply through by the whole divisor now. 3x squared times x is 3x cubed. 3x squared times 2 is plus 6x squared. Next step, subtract. Change everyone's sign. And we get 0. 4x squared minus 6x squared is negative 2x squared. I like to bring everyone down. You never know who you're going to need. And we say, what times x gives me minus 2x squared? And that's minus 2x. Minus 2x times x is minus 2x squared. Minus 2x times 2 is minus 4x. Subtract by changing everyone's sign. And we get 0. And then here we get 11x plus 22. What times x is 11x? Well, that's going to be 11. 11 times x is 11x. 11 times 2 is 22. But we need to subtract, so we change everybody's sign and get a remainder of 0. So this quotient is equal to 3x squared minus 2x plus 11. X to the fourth plus 6x cubed minus 7x squared minus 24x plus 12. And we're dividing that by x squared minus 4. Notice, x squared plus 0x minus 4. We're missing the plain old x term. We need that placeholder. Otherwise, things aren't going to line up. So we say what times x squared, because that's the highest power here, gives me x to the fourth. X squared does. Multiply through. We need that 0x cubed to be a placeholder. Minus 4x squared. Multiply x squared by the divisor. Now we subtract, and to subtract, we change everyone's sign. We get 0, 6x cubed minus 3x squared. Bring everyone down, because what we're really doing there's really a 0x minus 24x plus 0x is minus 24x. 12 plus 0 is 12. Restart the algorithm. What times x squared gives me 6x cubed plus 6x? Multiply through now. 6x squared times x. 6x times x squared is 6x cubed plus 0x squared minus 24x. Now we go through and subtract. To subtract, we change everyone's sign. And we get 0 minus 3x squared plus 0, 0x, we can write it there if we want to, plus 12. Now we restart the algorithm. What times x squared gives me minus 3x squared? Minus 3x. Multiply through, minus 3x squared plus 0x plus 12. This looks good because when I change everyone's sign to subtract, 0, 0, 0, we have a remainder of 0. So this quotient is x squared plus 6x minus 3. The key thing to take away from this problem is you need that placeholder of 0. You need your placeholders here. Otherwise, things won't line up nicely. Number 4, use long division to find the polynomial p that satisfies this equation. So right now it's written as a multiplication problem. But if I want to figure out p, I should probably do 2x to the 4th minus 3x squared minus 2 divided by 2x squared plus 1. And that will give me p of x. So it's a division question. So I need to do the numerator divided by the denominator. I have 2x to the 4th, but wait a minute, a term is missing, plus 0x cubed. The x squared term is there. I don't have an x term, minus 2. We need our placeholders for division. Divided by 2x squared plus 0x plus 1. We need our placeholders in both the numerator and the denominator. Could you do it without it? Yes, but it would be a mess. Use your placeholders. What times 2x squared, that's our highest power, gives me 2x to the 4th? Well, that's just plain old x squared. Multiply through now. X squared times 2x squared is 2x to the 4th times 0x cubed plus x squared. To subtract, we change everyone's sign and get 0, 0, minus 4x squared. And then we bring everyone else down because there's really zeros there. And now we restart the algorithm. What times 2x squared gives me minus 4x squared? Well, that's going to be a negative 2. Negative 2 times 2x squared is negative 4x squared plus 0x minus 2. And this looks good because when I change everyone's sign, we get 0 plus 0 plus 0, so we have a remainder of 0. So what's the polynomial p that satisfies that? Well, we know that p of x has to be x squared minus 2. And we can verify this algebraically by doing x squared minus 2 times 2x squared plus 1. And you would get back that quartic polynomial there, that 4th degree polynomial. Question 5, given q of x equals 3x cubed minus 4x squared plus 5x plus k, determine the value of k so that 3x minus 7 is a factor of this polynomial q. So if 3x minus 7 is a factor of this polynomial, that means something times 3x minus 7 gives me that polynomial. So to figure out what that something is, we should do division. So I'm going to divide 3x cubed minus 4x squared plus 5x plus k by 3x minus 7. So what times 3x gives me 3x cubed? X squared does. X squared times the whole divisor, 3x squared minus 7x, 3x cubed minus 7x squared. To subtract, we're going to change the signs, and we get 0 plus 3x squared. I'm going to bring everything else down. Now we repeat the algorithm. What times 3x gives me 3x squared? Well, x does. x times 3x is 3x squared. X times negative 7 is negative 7x. To subtract, we're going to change the signs. 0, and we get 12x plus k. Now we start the algorithm again. What times 3x gives me 12x? Well, 4 does. 4 times 3x is 12x minus 28. And we want to subtract. And I want to end up with a remainder of 0. So that adds to 0, and I get k plus 28. But I want that to be 0. So if I want k plus 28 to be 0, k has to be negative 28. So it's definitely a trickier question, but if something's a factor of the polynomial, that means something else times that factor gives me the polynomial. So we can do division to see what that missing factor is. Compute x squared plus 9 over x plus 3. What's different about this quotient? Explain your reasoning. So if I do x squared, I'm not going to do plus 9. I need the placeholder for that 0x there. So apparently something's going to be different about this quotient. So let's go through and see what happens. What times x gives me x squared? X. I get x squared plus 3x. I'm going to subtract negative 3x plus 9. What times x gives me negative 3x? Negative 3. Get negative 3x minus 9. But I need to change the signs to subtract, and I get 18. So what's different? Clearly we're left with a remainder. So something's different about this is we got left with a remainder. And we're going to talk about this more of why this happened in a future lesson. But what this tells us that x plus 3 is not a factor of x squared plus 9. Hopefully you remember from Algebra 1 that x squared plus 9, we can't factor that polynomial over the real numbers. So that verifies that x plus 3 is not a factor of x squared plus 9. All right, review questions. Find the solution to the system of the linear equations below. So this is a system of equations. The solution to this system is I want to make both true. I want to make all of the equations true. And hopefully you remember the method of elimination. Hopefully you remember elimination. So I need to somehow add these two equations together and get a variable to eliminate. So there's two ways to do this. You can get rid of the x, you can get rid of the y. I'm going to get rid of the x because I have the 4x and a minus 2x here. So I'm going to multiply that whole equation by 2. So I get negative 4x plus 4y. Don't forget to multiply both sides of the equation. Minus 16. Now if I add those two equations together, 4x minus 4x adds to 0. So I get 6y equals 6. Y equals 1. That's not the solution to the system. The solution is the point x comma y. So I plug it back in. 4x plus 2 times 1 equals 22. I picked the top equation. You could use the bottom equation. 4x equals 20, so x equals 5. So the solution to the system is 5, 1. These two lines intersect at the point 5, 1. If f of x is this function, find f of 1/2. So this means plug in 1/2 for x. Plug in 1/2 for x. So f of 1/2 is the square root of 2 times a half plus 3 over 6 times a half minus 5. To deal with fractions, deal with the numerator first, then deal with the denominator. So we have the square root of 2 times a half is 1 plus 3. 1 plus 3 is 4. Over 6 times a half is 3 minus 5 is negative 2. Square root of 4 is 2. 2 divided by negative 2 is negative 1. So f of 1/2 is negative 1. That means x is a half, y is negative 1. So the point 1/2 negative 1 is on the graph of that function. But that's the answer. F of 1/2 is negative 1. Number 9, solve the equation 2x squared plus x minus 3 equals 0. So when we solve a quadratic equation, we have three options. We can factor it, complete the square, or use the quadratic formula. First of all, it needs to be set equal to 0, so we're off to a good point. Let's try factoring it. First question, is there a GCF? No. 2, 1, and negative 3 don't have a GCF other than 1. X squared x, and there's no x, so we can't factor out an x. So hopefully you remember how to factor trinomials with a leading coefficient. We're going to come up with a more efficient way than guessing and checking, but I'm going to go through and do the guess and check way right now, but we are going to come up with a better way. Factors of negative 3 are 1 and negative 3 and negative 3, negative 1 and 3. So I need to end up with a positive x. So I'm going to try that combination. I get a negative 6x plus x. That doesn't give me positive 1. What if I do plus 3 minus 1? 3x minus 2x, that's what I want. Because 3x and negative 2x give me the x that I need. So this trinomial is equivalent to the product of those two binomials. They're multiplied and equal to 0, so I can use the zero product property that says that's 0 or that's 0. Solving this, we get 2x is negative 3, so x is negative 3 halves, and x equals 1. So the solutions to that quadratic equation are x equals 1 and x equals negative 3 halves. And finally, number 10, use the reverse tabular method to compute this. So we're dividing by x minus 1. It's x to the 4th divided by x. X to the 4th divided by x is x cubed. So I'm going to end up with a cubic polynomial. So I'm going to have an x cubed, an x squared, an x, and a number. So I need 4 columns. I get out an x to the 4th. I get out a minus 2x cubed, a positive 2x squared, a negative 2x, and a positive 1. So I know an x to the 4th has to be there. What times x is x to the 4th? X cubed. That's negative x cubed. After I multiply through, what plus negative x cubed gives me negative 2x cubed? Well, I need another negative x cubed. What times x gives me negative x cubed? Minus x squared. Multiply through. I need a 2x squared and I only have 1x squared, so I need another one. What times x gives me x squared? Plus x. X times negative 1 is negative x. I want minus 2x, so there's going to be another negative x there. What times x gives me negative x? Negative 1. Negative 1 times 1 is 1, as I desire. So the quotient is x cubed minus x squared plus x minus 1. That's lesson 3.